Okay, let's look at some questions from the problem sets for lessons 15 and 16 in Module 2. The lesson summary here says that the rules that apply for multiplying and dividing integers apply to rational numbers. Remember, rational numbers are any number that can be expressed as a fraction of integers. And so sometimes they look like decimals, sometimes they look like fractions, sometimes they look like just integers. We can use the products and quotients of rational numbers to describe real-world situations. Sure, okay, it's kind of what they're for. Number 1 says, at lunchtime, Benjamin often borrows money from his friends to buy snacks in the school cafeteria. Benjamin borrowed 75 cents or $0.75 from his friend Clyde 5 days last week to buy ice cream bars. Represent the amount Benjamin borrowed as the product of two rational numbers, then determine how much Benjamin owed his friend last week. Okay, so when I think of borrowing, well, I kind of think of negative money. I think of negative money or negative numbers when someone says, how much do you owe or how much debt do you have? But when you say how much someone borrowed, I don't think we should use a negative number here, because if I borrowed $5 from you, I wouldn't normally say, oh, I borrowed negative $5. So I'm going to use positive numbers here. I'm going to say that he borrowed 5 days. He borrowed, I'm going to use parentheses rather than a dot, just because dots next to numbers with decimal points sometimes looks weird. So 5 times 0.75. And then it says determine how much Benjamin owed his friend last week. So this is the 5 days times the 75 cents each day. Well, to be perfectly honest, I know a lot of kids like multiplying decimals. And if that's your thing and you want to stack these, and do one of these guys or whatever, go for it. Honestly, I hate that algorithm, and I could do it, but I don't want to. Instead, I would rather multiply 5 over 1 times, I know that 0.75 is equal to the fraction 3/4, and that's 15 over 4. And I know that every fourth of a dollar is a quarter, and so if I count by fours, I can go 4 would be $1, 8 would be $2, 12 would be $3. I have 3/4 of a dollar left over. That's 3/4, or $3.75. Okay, so 15/4, that's equal to the mixed number 3 3/4, which is $3.75. You could also use this algorithm over here too. You should get the same answer. Okay, number 3 says fill in the blanks with two rational numbers other than 1 and -1, because I guess I don't want it to be too easy. And so the numbers have to make this equation true. The first number you choose times -1/2 times the second number you choose equals -20. Well, you could pick any number you want for here, and there will be exactly one unique number that you could fill this spot with and make the equation true. But there's a better way to handle this problem than just like trying to guess numbers that are going to make this work. Let's think about, what if it was only one spot? What if it was just -1/2 times some number equals -20? And if we can figure out what that number would have to be, then that's really going to help us with trying to figure out the two slots in the actual question. Well, I see that I have a negative sign here, and I have to multiply it by a number and get a negative answer. That tells me whatever number I put here has to be positive, because a negative times a positive would get me a negative. And then I think, okay, 1/2 times something equals 20. Well, 1/2 of 40 is 20. So 1/2 times 40, -1/2 times 40 would get me -20. The reason that's useful for us is because multiplication is commutative, I should say. That essentially means that it doesn't matter what order you multiply things in, that you always get the same answer. And so if this question were write a number times some number times negative 1/2, that has to equal negative 20. Well, we could just put whatever numbers we wanted here and here, and as long as they multiplied to 40, then we would wind up with 40 times negative 1/2 equals negative 20. Well, we can still do that same thing, even though they're separated by this number, as long as whatever we put here times whatever we put here equals 40, then those things times this negative 1/2 will give us the negative 20. So I'm just going to pick two numbers that multiply to 40. I suggest you pick different numbers that I'm picking. How about we go with 4 here and 10 here? And then when I look at this, I think, okay, 4 times negative 1/2 would be negative 2. And you multiply that by the 10, you get negative 20. So it works. The question tells me I have to pick two different sets of numbers. So I'm going to leave the other set of numbers up to you, and I challenge you to make it so that the numbers aren't positive. What signs do the numbers have to be if you're not going to just use like a positive 4 and a positive 10, or a positive 2 and a positive 20, or something really easy like that. Okay, question 5 is basically the exact same thing as question 3, except this time they don't give you a middle number. You just have to find any two numbers that multiply to negative 0.75. My suggestion is to maybe use negative 3/4 instead of negative 0.75, just because I feel like it's easier to figure out numbers that will multiply to this fraction than to this decimal. And also, just remember that if this number is negative, then one of these numbers that you choose better be negative, and the other one better be positive. That's the only way to get a negative product. That's all the advice I'm going to give you for 5. I'm going to let you figure it out from there for yourself. And then for questions 6 through 8, create word problems that can be represented by each expression, and then represent each product or quotient as a single rational number. To represent as a single rational number just means to simplify the expression, or to solve it, see what it equals, whatever. So number 7, it says negative 6 divided by 1 1/3. Okay, so we have to come up with some negative quantity that we would need to divide by 1 1/3 for some reason. Quantities that I think of that are negative often, I think of money, like if you owe somebody, or maybe elevation, like when you go below ground or below sea level, that's negative. I think about temperature. Temperature can go negative, like when it's below freezing. These are the things I think about when I'm supposed to write a word problem with negative numbers. So let's see here. Let's use temperature. Let's say the temperature changed, or like the temperature dropped 6 degrees in a certain amount of time. So if temperature drops, we represent that change with a negative number. So let's say the temperature dropped 6 degrees. So I'm not going to write drop to negative 6 degrees, because that's a double negative, and that's essentially like a positive. So the word dropped sort of handles this negative sign for me. The temperature dropped 6 degrees. How about over the course of 1 1/3 hours? It's a weird way of talking about time, but a third of an hour is just 20 minutes. So it's the same as saying an hour and 20 minutes, but just in a weird way. Find the unit rate of temperature, I'll abbreviate that, temp change in degrees per hour. That's a blast from the past. Remember when we were doing unit rates and you were supposed to find something in degrees per hour or degrees/hour? That would mean to just take the degrees, which we said it dropped to negative 6, and divide it by the hours, which would be 1 1/3. So negative 6 divided by 1 1/3. Okay. Let's look at some stuff from the problem set for lesson 16. This lesson was all about trying to be strategic in how you multiply and divide expressions with multiple products and quotients. Actually, I'm just going to say products because remember, division is just multiplication by the multiplicative inverse or the reciprocal. And so I see them as just all products. What they want you to see here in number one is that if you were to just go from left to right, multiplying it in sort of like a brute force way, we would have, let's see here, negative 2.2 times negative 2 is positive 4.4. So I'm just going to rewrite that part, but I'm going to keep the rest. Divided by negative 1/4 times 5. I use a dot instead of the x. Then let's do this next part. I'm going to do the 4.4 divided by negative 1/4. Well, I'm going to do a little side work over here. 4.4, that's the same as times negative 4/1. So I have to do essentially 4.4 times negative 4. Well, let's see here. 4 times 4 is 16. And then 4 times this 4 would be 1.6. You add those up together, you get 17.6. But one of them was positive and the other one was negative, so it's going to be negative 17.6. And then we have to times that by 5. And that equals, well, you could stack these up if you wanted to, but I like to do it like this. The 5 times the 1 would get me 50. Well, really 10, but I said 1. And then 5 times 7 is 35. So when I add those two up, I get 85. And then 5 times 0.6 would be 3. So I add all that up and I get 88. One of the two things being multiplied is negative. The other one's positive, so the answer has to be negative. So it's negative 88. And so this way was kind of a pain because we had to do all that multiplication with the 4s and then this decimal times the 5. What we want to do this time in question B is do the exact same problem, but see if we can figure out an easier way to do it. And I already see it. I see that multiplying this negative 2 and this 5 is going to give us a negative 10. And then if we multiply that by the negative 2.2, well, multiplying a number by 10 just moves its decimal place over one spot. And so that 2.2 will become 22. And this problem just becomes a lot easier to do it this way. So I'm going to rewrite this as negative 2.2 times negative 10 divided by 1/4. So all I did was I chose to do the 5 times the negative 2 first. Now I'm going to do negative 2.2 times negative 10. And that's really easy because it just moves that decimal point over one spot, makes 2.2 into 22. And then since both things I'm multiplying are negative, the result is positive. And now I just need to divide this by 1/4. But that's the same as multiplying by 4/1, and 22 times 4 is 88. And so this lesson is just an exercise in being a little more strategic in what we choose to multiply first to see if we can figure out a way to make our lives a little bit easier. Both ways got us, oh wait, where did I mess up? This one's negative 88 and this one's positive 88. What'd I do? Oh, I see where it is. I should play like Dora the Explorer. Do you see where it is? There it is. I didn't carry this negative sign for the negative 1/4. So I'm just going to stash it up here. And then that means that this should have been negative. And that means that this times 4/1 should have been negative. And then now I have a positive times a negative, and that should have been negative. So be careful with your positive and negative signs. So this one, so question 3 is essentially the same idea. It's about this girl, Mia, who's evaluating this expression, and she's trying to do what we're talking about here, trying to do it in a strategic way, moving things around. But she messes up a bunch of stuff along the way to the point to where the question is asking you to like fix her mistakes as you go. But honestly, once you fix once you rewrite the first one with like her mistakes fixed from like the first one or two, there's like not even much point in like going back to her work. You might as well just finish it on your own. So I'll show you her first couple mistakes. I'm not going to finish this entire problem. I'm going to get it kind of started for you. I'm looking at the original expression. It says 0.38 times 3 divided by negative 1/20 times 5 divided by negative 8. And then this is the first set of changes that Mia decided to make. And I see that she changed division to multiplication here. And when you do that, you're supposed to take the reciprocal of what you're dividing by so that you can multiply by the multiplicative inverse. But instead, she changed from a negative to a positive. And that's what you would do when we change subtraction to addition. So she got her rules mixed up there. Instead of a positive 1/20 here, this should be negative 20 over 1. And then it looks like she did something else here. She changed, this used to say divided by negative 8, and now it just says times negative 8. She just changed division to multiplication without doing literally anything else. She was supposed to take the reciprocal or the multiplicative inverse of negative 8 over 1, which would be 1 over negative 8, or negative 1/8. And so I'm going to rewrite this line of the expression with the changes that I made. It's 0.38, okay, I guess I'll use the x like they're doing, times 5 times negative 20 over 1, which is just negative 20, times 3, if you can't see the 3 because I kind of hit it with the 1 there, and then times negative 1 over 8. I know here I have 1 over negative 8, and I just wrote it as negative 1 over 8. That's because you could put the negative sign on the top, the middle, or the bottom. They're all equivalent. I just prefer it in the middle or the top. All right, so now we want to be strategic like we did in the previous step. We want to find the things that multiply together nicely. And I see a 5 and a 20, and I know those things make 100 when you multiply them. And then I know that if I multiply this decimal by 100, it'll move the decimal point over 2 spaces and turn this ugly decimal into a nice whole number, which is much better for me. So I'm going to do 0.38 times, I'm going to do the 5 times the negative 20, which is negative 100. And then, no, I'm not. I was thinking about multiplying the 3 times the negative 1/8, but I'm not going to do that. I think it's probably better to multiply that by, well, I don't know. I'm going to leave it up to you. I'm going to leave you here. This is where I'm going to stop. I suggest your next step should be to multiply the negative 100 by the 0.38 and then continue on from there. All right, that's it.